Hello everyone, this is Praful. So today we are going to start our new topic. So welcome to the VLSI Cadence Virtuoso. This is our potential bias circuit, which we are drawing the common source amplifier in a potential divider bias. Okay. So this is the specification of our resistors and the capacitors and the voltages and all things. We have to draw this same circuit without any R sign, R small signal and anything R signal and load resistance of 10 kilo ohm. Okay. So first we are drawing this. So then we will find out the DC analysis. We got this is in region 2 so that it is working properly in saturation region, so it is an amplifier working as an amplifier, right? So then we will go through the transient response and the AC response, and then we will remove the source resistance, and then we will see what the effect or what the changes we can see in our outputs, and then we will finally calculate the bandwidth. Okay, so now let's start. New cell view, Profile C, new fifth schematic open. So my schematic editor is now open. Just press I, then DK, unity, this press cell to one mouse. Okay, let's take the ordinaries or predefined values. Let's take it, then we press escape, then I, then we have to change the library. We have to change to the analog lib, this analog lib, then we will change to this register. We will change the register values after we connect all the. Okay, so we have 22 server 4 resistors, then one resistor for this. Okay, then we have to introduce our capacitors. The capacitor is there. Okay, then I use voltage VDC. This is our voltage. Why we have to use our VLSI. Sinusoidal voltage. Then we have to introduce our grounds. So the grounds. We just introduce all these grounds. Okay. So I think now we have to just connect all these components. So now I think all the values are checked or connected. We have to change the values. Escape, then just press here. Then you have to change property. The register is 2 mega ohm, right? This register is Q. This is 1 mega ohm. This register is Q. 10 kilo ohm. This register is 2 kilo ohm. Right? Just change this to 5 U. Just change this to 0.1 U. Just change this Q to 0.1 U. Just change the values to you have to define as our DC voltage. DC voltage is 0, AC magnitude is 1. You can say offset value is 0, amplitude is 1 milliampere, and frequency is like 1 kilohertz. Change it 100 and 100 and just change this to DC voltage of 2.5, and I think all this is all the components values are now distributed 10, 100. Okay, so let's check and see. There is no error, I think. No schematic check complete with no error, right? So go with our ADEL. Just first we have to check the DC analysis. First we have to check the news. We have to check this global mode file. Okay, no problem. DC analysis. Just press STC. Component parameters. Select the component. This is my component. So now this is our DC voltage and enter. Then go to the choosing. Start time is 0 to 2.5. Just press OK. Right. Just run it. It will show all the values. If it is not shown, this is all the values. It is showing that 833.33 milliampere, 1.822 volt. Let's check that it is in reason or not. Just attenuation setup. We have to set the value, set the reason in our component parameters. Just use this component parameter. We have to choose this. No, is it not showing my reason? I have to change this attenuation view. This attenuation. This is DC voltage, DC operating points. Just show the DC operating point. This is my DC operating points is now showing. Okay. Just pressing view, automation again, then setup. The setup window is, I think, it's not here. And mouse. This is the parameter. This is my region. Okay, now it will show. So this is showing that this is in region 2, so it means that it is in saturation, so no problem in that. So our first objective is clear. Now we have to proceed further for our transient analysis. Just take a time of m and millisecond, moderate, enable this, and enter. Then just use from design. This is our output and this is our input. Go for the setting outputs, apply, OK, then go to the ADEL and just save and run it. So let's see what the result will show. So our voltage is high, that's why it is showing the high voltage of the second net too. This is showing, but this is also correct, right? So you can change the type to style to solid and just change the color to yellow. Okay, so this is we are getting, and this is our DC response. Okay, so now we can go for the tools, the calculator. Just take this VT, go to the schematic. There is my schematic. Nothing, there is my schematic. Just choose our ADEL functional. Now we need a functional. Then just VT again. Just click on this. This is VT9. We have to delete it. Delete. Then delete. Then just go to the functions which is showing here. The special function, I think we can use the bandwidth. You can use the bandwidth of B11, then apply. Okay. Wait a second. The bandwidth. Okay. So now just showing this. This is our 255.7 micro. Okay. So here is our bandwidth when the resistor is connected. Okay. So no problem in that. So now we are getting the output. Now we can change our circuit. How we can change our circuit? We can change it by removing the. Do you want to see the current? No, we don't want. We don't want. Just press delete. Just press delete it. Delete it. Delete it. Delete. Delete and then press W. Okay, So you can save and check, run, launch ADEL. Just we want only transient analysis, right? No. So you can use this 500 moderate and just enable, apply, OK. Choose the outputs from design. You can see this and this as my input, and you can see that this is okay. You can apply it. You have to go to the ADEL, it is showing there. Then just check the model libraries, it is already there. Now you can run. Let's see what it will show. So you can see that the second one value of V is now increased. Okay, you can change this. So there is a change, right? If you note the changes, actually I didn't save the previous one, so I not able to change this. So you can see after removing our resistor, the transistor, the amplifier is not that much good as when we have the resistor. So you can change this and we can measure the, what we can measure, we can measure the bandwidth. Just delete, just run. I think we have to run it. No, this is the previous one, right? We have to change this. We are waiting. Just go to the channel, press on this. Just go to the visualization. Press it. Enter here. You can choose one more thing. Choose this. You can use the function. Where is my function? The bandwidth. The bandwidth is VT11. Just apply, OK, and find the bandwidth. You will get this of first one, no problem. You can change it to the, you can change it to this function. Where is my function panel? You have to change the bandwidth of, is always showing this now. This is debug, apply, OK, and just run it. Let's see. So this is changed now. 240.5 into 10 to the power minus 6. So here is the change and here is the calculation of the bandwidth. You can calculate anything by this function table, but for this example we are going to only select the bandwidth. You can change anything. This is your homework. You can try anything. So this is all about our fifth module, right? So thank you. Good day.